Thank you. Can you hear me?
Yeah.
Can you hear me?
Yeah, we can.
Okay. Thank you. First of all, thanks to Knock for the opportunity of this presentation. Today, my topic of presentation is IPv6 status updates, and I would like to say hello to everyone here, Minglaba. I think it's still morning at your side. It's afternoon here in Brisbane. So first of all, before I talk about the presentation topic, let me give you a very brief introduction about myself. I'm Makito from APNIC. I am the network analyst and technical trainer. Currently, my responsibility is mainly delivering the training and providing the technical assistance to APNIC's members and stakeholders in the Asia Pacific region. Apart from my APNIC role, I'm also volunteering in TW NOC and KH NOC as the committee member. And also in the past, before I joined APNIC, I was mainly in the ISP and telecom industry. I spent approximately 2 decades in these industries. I'm also a MicroTech certified trainer. And long time ago, I was also a programmer, approximately 20 years ago. And due to the fact that I mainly work in the ISP and telecom industry, so you can see my areas of interest are mainly the routing technologies like BGP, MPLS, and IPv6. And from time to time, I'm still doing some coding and databases. Today, my agenda of the presentation includes my IPv6 experience when I was in Myanmar and why we need to deploy IPv6 and also some status updates in Asia, in Southeast Asia, and in Myanmar about the IPv6 adoption rates, as well as the common challenges and the IPv6 deployment planning. Okay, so let's talk about my experience. I actually lived in Myanmar from 2015 to 2021. During those days, I mainly provide some technology supports and training to the ISPs and operators in Myanmar. And due to this job, so I was very interested in IPv6 status in Myanmar. Until I left the country, I still try to see whether I can have the IPv6 FTTH service at home, but unfortunately, up to that point, it was not possible. If I'm not mistaken, at that time, only Mytel offered the IPv6 for the mobile users. I'm not quite sure about the latest development. If you know any ISPs are offering, feel free to share. And due to the requirement of my job, I actually tried to deploy my first IPv6 network in Myanmar back in 2017. It's a long time ago because my organization at that time was providing ISP solutions and technology training. So we would like to have the IPv6 network to support this. And of course, as a network engineer, I was always enthusiastic about running IPv6. And another reason is as a long-term friend of APNIC, at the time I knew APNIC would be very happy to welcome IPv6 deployment in Myanmar as well. So I just did it. However, because at that time, due to some constraints, either I don't have the upstream providers in Myanmar that support IPv6, and I cannot have the peering provider that I can get, many IPv6 prefixes. So most of the actually upstream providers or peering providers that I use was actually overseas. And what I did was like setting up the routers at overseas, including Singapore, Cambodia, US, and then try to tunnel the traffic back to Yangon either using 6-in-4 or MikroTik EOIP tunnels. And in the LAN part, I deployed the dual stack as one SSID. Another SSID was the IPv6 only with the NAT64 and DNS64. If you have a look at the trace route here, this one is the dual stack one. You can see it is reaching to microtech.com over IPv6. And then another trace route here is actually the IPv6 only with NAT64 and DNS64. It is like the SSID will only provide IPv6 and whatever destination will become IPv6 destination. Even that website is only IPv4. So the destination that I was testing here, it was IPv4 only. But with the DNS64, we created a fake IPv6 address, and then we use NAT64 to do nothing between v6 and v4. And because of the budget limit, also some technology constraint at the time, my experience was like IPv6 network was usable, but the performance of the network, of course, lagged behind IPv4. This is due to the lack of native IPv6 transit and peering locally. While our transit and peering were native IPv6 in Singapore, US, and Cambodia, but the backbone was tunneled over IPv4. So when you are using the tunneling, it will be like lower path MTU, and the point-to-point link latency will be depending on the international routing. In case of the good situation, I can get approximately 40 milliseconds to Singapore, but sometimes when international routing changes, then it can be much more than that. And of course, the CDNs were not optimized for Myanmar because my transit and peering points were all overseas. Another interesting experience was PTD, the Post and Telecom Department. At the time, they actually called us to explain why our network has peering with the foreign AS numbers. This is due to Myanmar has the strict control on the international peering. So like our case, our organization was not the international gateway provider. That's why by right, we should not have the international peering. But after we explained to PDD, it was okay. We explained to them that it's solely for the educational and research purpose. Okay, so what are the reasons that we should deploy IPv6? For myself, of course, I had a business case that requires IPv6. If you are the same, then definitely you need IPv6. Otherwise, there are some other reasons like not enough IPv4 to support your growing demands, because currently actually there are more people on the planet than IPv4 addresses. We have only approximately 4.3 billion IPv4 addresses. I mean, if you count all the addresses, including multicast and private IPs, but we have 8 billion people on the planet. And each person may have multiple devices. Just for example, myself, I have 4 phones, 2 tablets, and 2 laptops. So myself, I need around 8 IP addresses. IPv4 is running out, so how to do? Organization will soon be unable to apply the new IPv4 addresses from APNIC. So in that case, if they need more addresses, then either they need to go and lease from someone or buy it from the open market, which will cost $40 to $60 per address. It depends on the background of the address and the subnet size that you are buying. Sometimes it can be lower price, but just based on a personal experience, normally when the address is cheaper, then you need to check carefully about the history of the address. Technically, also for the router, it is more efficient to forward IPv6 than IPv4. This is due to IPv6, the header is fixed 40 bytes compared to IPv4, which can be anything more than 20 bytes. Although minimum is 20, it can be with the options and then it will be more than 20 bytes. So it is variable. And of course, IPv6 provides the end-to-end connectivity that we no longer need the NAT, the Never Address Translation, because in the IPv4 world, due to the address shortage, we cannot really assign each person a public IP. But in IPv6, everyone will have a public IP address, so you no longer need the NAT. So after understanding about why do we need IPv6, let's have a look at the statistic of the current status of IPv6. Currently, the world average of IPv6 adoption is approximately 42%, as you can see here. And in Asia, it's a bit higher. Asia is slightly more than 50. So actually, Asia is doing pretty well for IPv6. And if you would like to see the full report, actually the report is available in APNIC Labs. You can click on the link on the presentation slide, then you can arrive to the report page, and then you can see the detailed information about the status. Here is the list of the leading nations that deploying IPv6 in Asia. Currently, we can see India, Saudi Arabia, Malaysia, Vietnam, and Israel are leading. The top one is India with 77.84%. How about in different parts of Asia? Let's say in Southeast Asia, we have around 33.18%. This is for Southeast Asia, which is average in my opinion, because there are some other regions that they have slightly lower, such as Central Asia and Western Asia. And there are some other regions that they do pretty well also, like South Asia, 64.91. So which country is the top IPv6 adoption country in Southeast Asia at the moment? Currently, based on the statistic, we can see Malaysia, Vietnam, Thailand, Indonesia, and Singapore are leading. And for the Malaysia and Vietnam, they are more than 50%. Actually, if I'm not wrong, previously Myanmar was like around number two or number three in Southeast Asia, but in recent years, due to some changes, so the percentage of Myanmar became lower. It's 9.4%, 9.40% here. Then this one, we will have more discussion about it later. This is the timeline showing the statistic of Myanmar IPv6 capability and preference over the years. As you can see, started around 2019, and then after that, there was a time Myanmar peak at this point, and currently at this moment is 9.4 and 9.07. Well, 9.4 is the capability rate, and 9.07 is the preference rate. Capability means the user has IPv6. And preference means when the user has V4 and V6, the user is using V6 to access the internet. And this is the list of the AS numbers that enable IPv6 in Myanmar. We can see apart from the CDNs, mainly if you look at the operators, the major internet operators, you can see Mytel here. This one, Telecom International Myanmar is Mytel, is at 35.39. And then Starlink is at 28.88. While Atom is 10.06. And other ISPs are almost no IPv6 at the moment. At least from our statistic, this is what we can see. So what happened to Myanmar? Actually, based on the statistic, we can see in the past, Myanmar used to be relatively high, but dropped significantly in recent years. Started from 10% in 2019 and peaked at 58.85 in 2022, but started to fall below 10% after mid-2024. And currently, as we can see on the list that I showed just now, Mytel and Starlink are the key contributors for IPv6 with their capability rate of 35.39 and 28.88 respectively. Other major networks show little to no IPv6 adoption. But I personally feel interesting that whether Starlink is even legal in Myanmar, but based on our statistic, we can see it is quite high. So about the decline, this is our observation. IPv6 adoption rate dropped since the July 2024. This is the statistic over the year. As you can see, the peak point is 58.85, while the June 2024, it was still 48.33. But after July, it became 11.58. So there must be something happening between this June and July. And since that time, it was below 10% until the latest statistic that I captured last week before I submit the slides, it was 9.4% only. I actually don't know what happened. That's why I talked to many of my friends, previous customers, and some people working in the IGW in Myanmar. Then some of them gave different opinions, and here are the summary of the opinion. So some people told me Deep Packet Inspection or DPI was implemented at IGW networks around July 2024. Since that time, content filtering became stricter and more granular, and major social networks that might be using IPv6 were banned. And as a result of this, also users tend to use the VPN for accessing the restricted content. And most VPN services currently primarily operate over IPv4. So this is the feedback that I received. And of course, come from different operators, there are some other feedbacks, such as the services were impacted by the implementation of DPI, such as high latency, unstable bandwidth, or sometimes some legitimate services can be blocked without reason that they have to solve specifically for that. Also, there was ISP told me that they were encouraged to provide IPv4 instead of IPv6. Someone also said IPv4 content filtering is easier to manage because they have better equipment support and less configuration complexity. This is in their case. And one major operator told me that their IPv6 users were targeted by the botnet attacks because the users were using public IP and they were unable to purchase the suitable equipment for mitigation due to the international sanction. So finally, they have no choice but to turn off the IPv6. This became their solution. Also, some ISPs near the border areas, they told me their customers are mainly the scamming businesses. So those businesses rely on IPv4. That's why they are not doing anything for IPv6. Here are the feedbacks that I received from the operators. And based on the feedbacks, I can identify that those points fell into followings, such as the legacy network upgrade that can be because of the equipment may not support IPv6, that it is a challenge for deploying IPv6. And some ISPs, they have concern on the security that the user is using public address. That's why they concern about their user being attacked. And also some ISPs, simply the policies and services still prefer IPv4. And apart from these reasons, actually in different countries also might have other reasons that can be the challenges of implementing IPv6, such as new skills required. Some networks, their engineers know very well how to operate IPv4, but not really IPv6. Probably they need more training or more testing before they can do the implementation. And probably some country, they have enough IPv4 addresses, specifically like Hong Kong and Singapore, they have a lot of IPv4 addresses so that they don't have the immediate reason to implement IPv6 due to IPv4 shortage. Or probably some networks, they have a lot of money to list or buy IPv4 addresses. So in that case also, it can be an indirect reason that they don't implement IPv6. Anyway, although with many different reasons or difficulties, eventually IPv4 will run out and IPv4 will be more expensive to operate from time to time because IPv4 address prices now still remain high unless one day most of the networks they are changing to IPv6, no one needs IPv4 anymore, then in that case IPv4 price will drop significantly. And also CGN equipment cost. I believe this one in the previous presentation already explained about the role of the carrier grade NAT, about why we need the NATing. It is simply because of currently if we are using IPv4, the ISPs likely they will assign the IPv4 private address to the customers. So they will need to do one level of NATing in the ISP network that we call carrier grade NAT. But carrier grade NAT equipment is not cheap. It can be quite costly if you have a big network with many subscribers that you require the big bandwidth. So those things are the long-term costs that you will need for running IPv4. So still the suggestion is, if possible, should try to plan for IPv6. And in case if you are considering to deploy IPv6, you can consider following steps that we divided into three parts here. First of all, the strategy and preparation part. You can do the planning and governance, and then you can conduct the network assessment, see what are the things in your network currently. For example, whether the equipment support V6 or not. If not, how to upgrade the equipment, whether it will cost money or the equipment is upgradable. Sometimes maybe you cannot upgrade the equipment due to it is end of life or it is too old. Then in that case, you may need to buy the new equipment those will be the challenges because eventually when the engineer propose the solution to the boss, if it is too expensive, then the boss will not accept it unless there is a business case. And in case if you are okay with the equipment support, you can do the upgrade. Then next you can do the optimization of the existing network, such as some of the routing protocol configuration in IPv4 that you did not do well in the past. Probably you might want to improve it before you put another protocol for IPv6. And you also need to consider like the IPv6 transition strategy. For example, whether you want to do the IPv6 at the edge only and then your core is running MPLS, or you want to run dual stack IPv6 throughout the network, or probably you want to consider the technology like 464 XLAT or IPv6 mostly, then this is your transition strategy part. Then next we will continue to the capability and design, which we will identify whether the engineers they have enough knowledge and skills to run and operate the IPv6 on a day-to-day basis. If not, then what kind of training, or whether you need to recruit the new people. If you need to recruit the new people, then probably it will come to the costing problem again. And in case if the skill and knowledge can be solved, then next one would be to apply for the address space. This one you can apply from APNIC. Typically for the ISP, you can get a /32 from APNIC. And for the enterprise also, you can get /48 from APNIC. And after getting the address space, you can start to develop your IPv6 addressing plan. It would be like planning which block to use for the infrastructure, point-to-point, loopback, and which block to use for customer. Then a good addressing plan would help you a lot in the future, especially for the ISP situation that you may want to do load sharing between multiple upstream providers. So in that case, if you do the sparse allocation to your customer would be quite good. It means that don't assign the address of the customer next to each other, but assign them in the different blocks so that when you do traffic engineering, it will be more flexible. And next, it would be to build the test and pilot environment before actually implementing it. This is very important. Some of my clients in the past, they did not have the test network or pilot environment, so that when they wanted to implement something, they needed to plan very well. Otherwise, when actually implemented, if something wrong, it will cause the outage and impact to the customers. So I suggest at the very least, you can try to make the test, maybe a smaller scale of test network to test everything, make sure the protocol is running. Let's say when you are enabling IPv6, you will need to run IPv6 routing protocol. You might need to do IPv6 rate limiting. You might need to implement IPv6 firewall filter. So in that case, you may want to test everything and make sure that they are okay before you put into the production. Then the next part, if everything is ready, then it will be deployment and operation. For deployment, you will implement the IPv6 according to your addressing plan, configure the routing protocol, enabling the BGP session. And next, you will choose the IPv6 transit service. Ideally, if you can use the same provider for IPv6, it would save the cost and it would help you to maintain the consistency in the routing policy, as most of the providers, they may have similar routing policy for IPv4 and IPv6. And for number 11 here, enabling the IPv6 for the customers, I would say this is one of the most challenging thing for the ISP, because for the ISPs, some ISPs, they may deploy the IPv4 only CPE in early days. So suddenly when they need to enable IPv6, maybe thousands of their customers do not have the CPE that can support IPv6. And if they would like to upgrade the CPE, it would be an additional cost. If customer is not willing to pay for that, then it will be a burden to the ISP. And again, if you are the technical staff that trying to propose this, when you are going to the management for the approval, the management will have the question that why do we need to spend this money just for enabling IPv6? So it would introduce additional difficulty if the equipment upgrade is needed. And finally, point number 12 is after implementing, the daily operation monitoring and optimization is also very important. I have seen some administrators that they implemented IPv6 on the server, and then after that they just forgot it. It's like they don't maintain it anymore. They don't even bother to put a firewall filter on it. Or even sometimes the IPv6 service did not work for 3 months already, but they did not realize because most of the users are using IPv4. So this point is important. If you implement something, implement IPv6, make sure you operate it and monitor it. And of course, you need to do optimization from time to time. In case if you are going to implement IPv6 and you need help, depending on what kind of help you need, if you need the resource like IPv6 addresses, then it will be APNIC. APNIC has a page about IPv6. It is the link here, apnic.net/community/IPv6, or you can also visit our help center. In case if you need money, then it is from Information Society Innovation Fund or ESIF Asia grants. This one it is the grants that you can apply. Let's say if you have a project that you want to implement IPv6 and then you need money to implement it. Probably, let's say you need $50,000 to implement it. So you can write the project proposal and submit to ESIF Asia to apply for the grants. And in case if your proposal is accepted and you are awarded with the grants, then you will have the money that you need for implementing the project. I also suggest you to have a look at this link. Yeah, that's it for my presentation. Thank you very much for your attention. In case you need any support or you have any question that you would like to contact me, then just email to me. My email address is on the slide, or if you want to connect with me on LinkedIn, also feel free to scan the QR code to connect with me. Thanks for your attention.
Thank you so much, Mr. Makito, for that important update on IPv6. Now we have fun quiz session.